Well, thanks, Joe, for putting this whole program together, and thanks for inviting us, giving us the opportunity to come and share a little bit of the work that we're doing. What I wanted to do is kind of give you guys an idea of, we've kind of been through how we collect the data, how we select sensors, how we select the play. So what I wanted to do is just give you guys an idea of what we do with the data that we're getting out of this technology, right? So first of all, the main question, at least for us that are in the business of science, we need data, right? So either to prove or disprove something, we need numbers. We need data to be able to say something about it, okay? So where does this technology here fits for us, agriculture field? Is it to fulfill Dr. Landivar's dream there? So if you notice there, not long ago, in the 1990s, this here is Dr. Landivar. And what backpack there? Well, that backpack is a GPS unit, right? So long ago, in the 1990s, that was the state-of-the-art technology. He had to walk with his measuring stick, okay, collecting the plant height data, and then logging it on a computer there, and the GPS on his back to mark that point, right? So depending on the size of the field, you might, to collect a measurement as simple as, okay? Now you move about 10 years forward, and we start looking at this type of technology here, okay? So we have now different sensors that are mounted to a tractor. In this case was a modified spray rig, okay? So that's a little better, right? You don't have to be walking and carrying stuff, you're just driving. Now, you're still gonna take several hours to collect measurements as simple as plant height data. You might be collecting other measurements as well along with your plant height data. But, it's still expensive, it's cumbersome, and not ideal, let's say. And one of the other things here is that moving from manual data collection to using the tractor, you get a little bit better sampling, but you're still at the level that the UAV can provide. Okay, so we started working with the UAVs in 2015, and this technology here provides us continuous sampling. Okay, so we can come in, collect data twice a day, every week. It just allows that flexibility. And let's say for the same size area that you take you maybe a day or two, you take hours here, and right here we can do it within minutes. Okay. So the end result, like I mentioned, is we need to have data to be able to say something about something, right? So if you look here, this is actual data that Dr. Landivar collected in the 90s, in 1997, the King Range. Okay, so if you look here, he was mapping that field, and you can see the plant height data here. Okay, so these are shorter plants, and these are taller plants there. Okay, but then if you have a point here and you have a point across the room, what you're doing is that you're trying to interpolate from this point to that point to get an idea of, what your plants might be looking like from here to there, but you don't have that measurement. You're just trying to, right? If you look here from the tractor, you get a little bit better sampling, but still, from one point to the other, you're trying to take a guess on what your plants might look like. Now, if you move here and look at the UAV, this is an actual map that we produced in 2015, and that map contains plant height data for every meter square of the field. Okay? So we go from a couple of points here and trying to guess what your plant point to the other, to being able to actually get the information for every meter square of the field. So like I mentioned, plant height is such a simple measurement. If you think about it, all you need is just a measuring stick and then maybe a piece of paper with a pen, and you can go and take your measurements, right? Now, we can get a lot of information, biologically speaking, we can get a lot of information of what's going on with the crop just by looking at plant height data. And that data actually takes a long time to collect, So, but the thing here is you need to have good data, right? So, I mean, it's not just data, it has to be good data. And so what I'm showing you here is plant height data. This top graph here is for an example for cotton, and this here at the bottom is an example for sorghum, okay? So on the y-axis for both graphs, what we're looking is measured plant height data, which means we went out to the field with a measuring stick and actually measured those plants, right? And then here on the x-axis for both, again, we have estimated data from the UAV, okay? So these are UAV. And then if you look, this dotted line that goes across both graphs there represents your one-to-one line. What that one-to-one line means is if I get a measurement with my, let's say, a plant of 1 meter, and I fly my UAV and get my measurement from that same plant from the UAV and get a 1 as well, that means that point would fall right on top of that line. Okay, so that means our measurement from the ground and our measurement from the UAV, okay? They're not quite perfect, you know, they're not quite all falling on that line, but still, that looks very good. Okay, for us, if I'm given the choice between going out there with a measuring stick, collecting my data, or getting my measurements from the UAV, if I get a relationship that looks something like that, I'm fairly confident with the UAV data, okay?
So we don't need to hire technicians.
Right. Well, at this point, we're hiring them so we can actually do these kinds of things, right? So like I said, you know, we need data. So to be confident with that data, we need to prove, or in this case, we need to validate the data we're getting from the UAVs with, right? So the strategy, you've seen this figure here before, but our strategy here is feet, okay? These are meters squared, and we can get all the information we can get from one grid, we can get for all of them. Okay, so we can get for a specific field or a specific area, we can get information for every meter squared of that field. And then here, what we're trying to do is, because of the flexibility that the technology allows us, is that we want to track what's going on with the plants throughout the season, right? So from planting all the way. And the idea here is that a combination of information or data that we're getting throughout the season should be able to give us an idea of what the performance or what the yield of that plant is going to be at the end of the season, right? So an analogy here is if you think about, you know, if you're buying a car, a used car, okay? So the records of how well that car was maintained, you know, is a pretty good indication of whether or not it's going to perform at the level it's supposed to. Right, so if you don't do your oil changes, if you don't change your tires, and when you buy your car, it's probably not going to be up to the performance where it should have been, right? So the idea here is the same. We're trying to collect data over the season and then come out with an idea of what is the performance of that plant at the end of the season, right? So what is the... So how are we doing that? You've seen this before as well. In this case here, we're looking at, okay, so this is percentage of ground that's covered by a canopy or a plant. And then here we have days, okay, so from planting forward. So every time we fly, we get a point, okay? By the end of the season, you have a curve that looks something like this, okay? From there, we extract the first derivative. Dr. Landwehr mentioned this, and we get a growth rate. So in this case here, we're looking at percentage over time. And here we're looking at the growth rate in percent per day for each day, okay? So this gives us a level of detail on information about the plant that's just amazing. You know, scientists never had the ability to have this kind of data before, okay? So this opens up a new, let's say, level of detail of what's going on with the plant. What's interesting here is that not only collecting your data, but how you look at your data is also important. This here happens to be data for the same plot, okay, so the same row of plants. In different ways of the same points here are shown up here and up here. We're looking at a model that is a symmetric model. What that means is that this side of the curve with this side of the curve are the same, okay? But the model is forcing symmetry there. And then down here, again, it's the same set of data, but over here we're looking at a 4-parameter logistic asymmetric model, okay? So that gives us different numbers for side and that side, which is how plants are supposed to be, right? Plants, they're not symmetric throughout the way it's not symmetric, right? They're always responding to the environment. It's a little faster, might hit some drought, slow down a little bit. So this here gives us an ability, a better ability of understanding with that plant. Now, those graphs there were for plant, for canopy cover. But like I mentioned, you know, we're looking at several different parameters that you saw were mentioned this morning. So if you look here at the end of the day, you know, we're looking at plant growth, height, canopy cover, canopy volume. Okay, if you look here from NDVI red, we're looking at canopy efficiency parameters, or how green that plant is, or how is it responding, might be responding to drought stress. And then down here, these are specific for cotton. These are yield-related parameters, right? So we're looking at bloom counts and boll counts here, okay? Dr. Landevar mentioned this before, but you know, you end up with a whole bunch of parameters that you're extracting from your UAV data at the end of the season, and a combination of some of those should explain the yield you're getting at the end of the season, or how your crop is responding to the environment throughout the season. So here it just shows you what I'm showing you here is just of this technology here to help us predict yield or estimate yields. Okay, look here at the y-axis here. We're looking at measured pounds of seed cotton per row. Okay, and over here we're looking at predicted, again, pounds of seed cotton per row. Okay, and then again, that one means if the two numbers, they'll fall all within that line. Okay, so here what I did is I was using 6 different parameters from our UAV data. Okay, that included growth, included canopy efficiency, and then boll parameters. And then here I'm just comparing them. Okay, so we're getting an R square of about 0.74.
Murilo, you selected 6 parameters
out of 60. Out of this list here, 60. It wasn't, I didn't select them manually. I ran them through a software, a statistics software that selected those 6, okay? And from those 6 selected, I developed this model here to predict, okay? So from 60, I went down to 6, which is what I'm using here to predict the yield. Okay, and just to precision farming before I move on, because I want to give you guys a little demo of a website that we're using to collaborate. This technology here is going to allow us to develop applications for our farmers to do a lot better job at being with the farm inputs. Okay, so here what I'm showing is a cotton field. Okay, you can see that we had some skips there, some plants and whatnot. And what we did here is that we developed a map for plant growth regulators for cotton. Okay, and again, these are for every meter square. So here, depending on the environment that you have, let's say if you have irrigation available, plants are not constrained by the lack of water, they're going to grow. Cotton usually you can difference, you may want your plants a little taller, a little shorter. So in this case, you'd spray more plant growth plants shorter. If you have a dry environment, okay, you would spray less. So I don't know if you guys can see there, but these are darker, more, and these are lighter, you'd spray less. And then there are some spots that you don't even have to spray at all. Okay, so what you're doing is saving money on not having to spray where you don't actually have plants, right? So this is just an example for plant growth regulators, but you know, maps like this can be constructed for cotton root rot, for nematodes, which then you're talking about a lot more expensive products than plant growth regulators are. Okay, so just to give you an idea there. So real quick, I know I'm running out of time here, but I just want to show you this website that we've put together. Now, one of the biggest problems or challenges that we had very early on in the program was to share that data, okay? So as you see, we collect a lot of data, a lot of images. Those images are once they're processed, it's a lot of data, okay, to be transformed. So one of the things that we've put together here to address this issue is what we call the UAS hub. We're looking here is just an example of a cotton trial that we had in 2000. Okay, if I scroll down here, you're seeing data that was collected and processed. I have the dates here, and then whether that was processed or not. So I'm just going to click here. And it's going to load image, okay? So I can zoom in or out, and what the web page is doing is just loading the level of detail that I'm looking for, right? So I can zoom in and give it a second, and it's going to load the higher resolution images. Okay, but what I wanted to show you here is, you know, we've been talking canopy cover. So what I did there is just click the layer for canopy cover, see those squares or grids, okay? So I can click on each one of those grids, and it's going to tell me what is the canopy cover for that particular grid. So I have information about the variety here, okay, where it was located in the field. But then if you look here, where it says CC 0.31, that's 31% canopy cover for that meter square, okay? And then I can click any one of those, and I'll get a canopy cover for that particular grid, okay? The other thing that's available here to us is to be able to look at bow counts, okay? So these are important for us if we're trying to estimate yields. So let me zoom in a little bit, and let's say I can click on this one, and it's going to show me that the number of bows that the computer or the software was able to count on this plot here was 456, okay? Compared to something like this one, 539, okay? So there's a lot of information that we can get from this here. Let me just jump to it real quick, and then I'll stop. Here.
Each line is a study with that.
Yes.
Someone,
So, you know, again, if I scroll down here, in this case here we had some color infrared, or you can see here CIR, okay? So here is it just 8, and then it tells me whether or not that data has been processed and it's available here for me or not yet. So I can scroll down, and you can see that this is last year, a whole bunch of flag. So I'll go back here. And then what we had here, this field up here was a dryland field, cotton field, and then down here we had an irrigated field, and right here we had some sorghum. So let's see, I can click here, 420. Go down another month, okay. And then I can go some more. Go sometime in July. August. And then at this point here, you can see that we start seeing some open bows, okay? And I can zoom in, and it takes a second, but it, you know, it loads. And you can keep zooming in, and you can see a lot of detail there, okay?
Every 2 rows is a variety.
Every 2 rows here is a variety, so I could come up here and turn on the plot boundaries. Okay, I can click on this one here. It'll tell me the location of that variety. It'll tell me the entry, the name of that variety. It'll tell me the breeder. In this case here, it's Dr. Stelli's variety. And I can click on growth analysis, and you'll load the models that I was showing you earlier. Okay, so I have here canopy volume, height, and then cover. So let me close this. Close that. And there is just one last thing I want to show you guys. It's pretty cool stuff. Where is it? July. Right here. Okay. So what I want to show you here is this sorghum field we had over here. Okay, this is let me turn off the other one. Dr. Bill Rooney's sorghum breeding field. Okay. Let me turn on the boundaries like this. And you can zoom in, and again, as you zoom in closer, you load the higher resolution images, and you can zoom in to the point where you can see all the panicles there, right? Now the interesting thing about this, I'll pick this one. Notice this gap here, okay? So Dr. Sterick and Dr. Jung were talking or telling you guys about, you know, how we can actually get 3D structures out of images, okay? And here's the example right here. So I can click that, and what it will do, it will load to me a 3D image of that plot, okay, that particular plot. And you can move it around. Now, if you want to study the roots, you do no, just kidding. But you know the information then that we're getting as far as plant height and canopy, you know, all of it or most of it come out of this 3D point cloud, which is what we're seeing here. Okay, so you can zoom in, and you can actually get measurements out of this. Okay, so I could click here and go down here, okay, and that plant was a meter. Okay, what do I do? Here, okay, so that plant is a meter. Now, we don't want to be doing this all the time. We'll let the computer get these measurements for us, right? So I'm just showing you here that that's possible to do. Okay, so you can get as close as this, you know, to be able to get measurements from panicles. All right, so you can get size, length, and width of those. And I think Dr. Chang is going to talk to you a little bit about this. So I'm going to stop here. And before I end, I just wanted to acknowledge here my coworkers. Obviously, you know, I'm here showing the work of a big group of great people working together. So, you know, I just need to make sure that I acknowledge my coworkers here.
You know,